Welcome back to Finding Your Place in AI Ethics Consulting. And so now we're going to focus on the more technical aspects of consulting in this field. And in particular, we're going to talk about algorithms, AI, and machine learning, or learning machines. So it's undeniable that a knowledge of modern AI and machine learning techniques is critical. It's really important for understanding emerging risks because it's the nature of these algorithms that a lot of the risks arise. And bias is a particular one, which we'll talk about in the next lecture. But a lot of what we do is helping people develop AI responsibly. And so we need to have knowledge and understanding and experience developing AI systems. So beyond just identifying the risk, this consulting around responsible AI really brings in best practices throughout the whole development cycle. And so if you are a developer, if you have experience working with data, working with machine learning, there's definitely a place for you in AI ethics consulting. So some of the example tasks that you might find yourself doing, and this again is biased, this is the kind of things that we've done in our practice. Collecting training data and doing it ethically. This is something that clients often need help with. And even when we're not helping clients do this, if we're testing the system for bias, which again I'll talk about in the next lecture, we might have to collect our own data. And I'll show you some examples of that in a minute. You have to label data. So you either are helping clients with setting up some UI for them to label their own data, or if it's our internal data or whatever company you're working for, you might have to be either labeling the data yourself or setting up some system that will allow or facilitate the labeling of data and doing it responsibly. Exploring and testing potential machine learning models. So helping people do this responsibly also means, finding the right model. You have to find the right algorithm, the right system, the right architecture that's fit for the problem. And that's something that you need experience doing. Sometimes you might be building a dashboard for displaying data. So that could be a dashboard for either training data or just data coming out of the system for monitoring afterwards. We've had cases where we've constructed Python notebooks and templates that would facilitate clients exploring the data themselves or trying to find some insight. Explainable AI research. I've mentioned this before. In the non-technical tasks, but there are technical aspects of actually generating explanations for certain AI models. And so having the technical skills to be able to understand and either develop your own or use sort of out-of-the-box solutions. And then also constructing and monitoring solutions. So we're going to talk about bias in the next lecture, but definitely anybody who's using machine learning models that might evolve with time, constantly monitoring the model to make sure that it's appropriate and still unbiased. Even if the model itself is not evolving, there's a chance that the data that's coming into the model has shifted and the distribution is different than the one that was trained on, and you still need to monitor that and make sure that it doesn't need to be retrained. So these are all just examples of sort of, the kind of technical things where if you have experience working in machine learning and just plain old coding, you can find a place. And so this is an example of a data set that we actually had to collect for doing testing for bias. And so, there's a lot of the non-technical tasks where we have to, gather stakeholders. We have to, in this case, we actually interviewed them and asked them questions about the ethical problems that they were facing regarding this technology. and had to collect the data. But then there's a whole bunch of data wrangling after that. And so we had to set up a whole pipeline in order to process these data and make sure that they were appropriate for the testing that we're doing. And this required quite a bit of coding, actually. And when you have data sets like this, you might be helping clients document them, right? So this is a template that we constructed from the data sheets sort of template. And so we just put that into a Colab notebook. If you don't know what a Colab notebook is, it's just a Python Jupyter notebook, which is hosted by Google. And so we actually made a template so that we could display plots in addition to all of the other information about how we collected the data set. So these sorts of things are typical of the kind of things that you might do on the more technical side. And then there's the machine learning itself. And this is one of the things that people ask me the most about, probably. How much machine learning do I need to know in order to get into this field? So the answer to that question is you need to know quite a bit in order to identify risk, but you don't necessarily need to have developed machine learning models. However, if you are going into this specific technical area where what you're bringing to the table is your knowledge of machine learning and your experience in machine learning, you need to have had significant experience and really understand the nuances of machine learning, and also be keeping up with sort of the modern trends and what's coming out in terms of new models and new architectures. So most of what we're dealing with are automated decision systems. So these are systems that make some sort of decision automatically. It could be some sort of credit scoring. It could be some sort of lending decision or a recidivism decision. But oftentimes it's not just that. It's some sort of information which is provided to augment a human decision. And so that's why I have automated decision augmentation systems. And there's a bunch of different methods that people use to develop these kinds of algorithms. It's not just AI. So a lot of times it's just plain old explicit programming. And that just might be some rule-based or some sort of logical structure, a formula. That's explicit programming, where someone just wrote. Expert systems are an example of this, where you have all of these rules. You try to encode knowledge in a particular way so that you can get a decision out the other end. And this was very, very popular, since computers have been around. Then there's also planning and optimization. This is different. This is not machine learning. This involves things like search and optimization techniques, where you're sort of searching a parameter space for a solution. It's not really learning from data. It's taking a given situation, what the system knows about, let's say, the environment or the variables that you give it as input, and it's searching through that system or that parameter space and optimizing for something. So it's not technically machine learning. And then we get into the sort of the learning machines, the types of algorithms where machines can learn from data. Reinforcement learning is a big one, and I'll talk about that, all of these more in a second. Reinforcement learning is simply the case where you have an agent that is interacting in real time with the environment, or it could just be with data. It could be a virtual or a real environment, and it's interacting with that environment, whether it be sort of mimicking the real world like in a video game, or it could just simply be data. It might be that it's interacting with the way people are clicking on a web page and trying to optimize for some objective. So reinforcement learning will essentially penalize or reward certain actions and try to build up a policy or a model that's going to have that system interact in a way that you want it to, based on some objective. There's also supervised learning, and this is the one where most people think when they think of modern machine learning, they're thinking about supervised learning. And so that's just where you have data that is labeled in some way, So it could be a bunch of pictures of cats and dogs, and they're labeled as cats and dogs. And the system will sort of learn how to identify cats and dogs based on that data. So some of supervised learning is what we would call good old-fashioned AI. Things like decision trees and linear regression and that sort of thing. That's machine learning and supervised machine learning. But it's not what most people think nowadays, which is neural networks, and in particular deep neural networks or deep learning. And that's where a lot of the frontiers are being pushed currently. And there are all sorts of different kinds. I won't go over them here, but there's convolutional neural networks, there was recurrent neural networks, there are transformers, all of these language models that you're hearing about, the natural language processing. They use some sort of transformer or attention-based networks. And so there's a lot there to study. And these are the places where you do need to spend quite a bit of time sort of making sure that you are comfortable, and not just comfortable. You need to be comfortable if you're doing this for risk analysis, but you need to be proficient and actually be able to develop these sort of systems if you want to actually work directly in AI and machine learning, even in AI ethics governance. Then unsupervised learning, which is typically clustering or pattern recognition, which just is looking at unstructured data or unlabeled data. And then there's also semi-supervised learning, which is sort of a combination of supervised and unsupervised, where some data is labeled, some data isn't, and you sort of use a mix of techniques from both of them. So the question is, how are you going to get these skills, right? So either you're a machine learning engineer and you already have these skills, or perhaps you are interested in AI ethics and governance, but you're also interested in machine learning and you'd like to sort of try to focus on that particular area and strengthen yourself in those areas. So where are you going to get the training? So if you just want to get an idea of how this works, there are a bunch of free courses out there. There are so many of them. And there are a lot of paid courses as well. And so this is one that's, if you want to sort of look at general machine learning and how it's used in sort of a modern workflow, Google has a great sort of machine learning crash course. It's free. It uses TensorFlow, which is fairly popular as a framework for doing machine learning. PyTorch is another one which is quite popular. And so this one is a great one. It's not, it requires quite a bit of mathematics. You have to understand, but machine learning in some sense, or at least programming a little bit. But it's manageable for someone who just has a little bit of Python experience, programming in Python, and a little bit of sort of linear algebra and calculus. So a little bit of basic math. Now, one of the ones that I found most useful is a free course in Udacity called Deep Learning. And this, if you're really focusing on understanding deep learning techniques, this one is a great one. This does get into the details of the mathematics, but it's actually quite easy to understand, even for somebody who has just a sort of superficial understanding of linear algebra and matrices. You can kind of understand what's going on under the hood, even if you don't have a really deep knowledge in mathematics. They sort of bring you up to speed. So I definitely recommend looking at this free course. It's quite good. Now, if you want to do reinforcement learning, in particular deep reinforcement learning, OpenAI has a whole resource on what they call spinning up in deep RL, or reinforcement learning. This one is a lot more advanced, and so the mathematics required for this is a lot more difficult, and I would not recommend this for someone who doesn't have a background in science or engineering or mathematics and some programming experience. And so this is something that if you are advanced, you have those skills, then this will bring you up to speed on the really modern techniques quite quickly. And in fact, OpenAI was one of those companies where they came up with a lot of really big innovations. And so GPT, which is a really big language model, GPT-3 in particular now, is being used all over the place. And they've also done a lot of really interesting reinforcement learning where that they've shown that there can be this really interesting emergent behavior coming from fairly simple models of reinforcement learning. So it's a great place if you really want to dive into that field. And so a question I often get is, do I need a degree or certification to do AI and ML as an AI ethics and governance consultant? So if you're asking, do I need a degree or a certification to work as a machine learning engineer? I'd say absolutely yes. Of course you do, right? You need to be trained in that field. But in AI ethics and governance, as you saw, the level that you need to know is slightly less, and you need to have more of a focus on the responsible development of AI. You still need to know and be able to do and use the modern techniques, but you don't necessarily have to know all of the details of how a whole machine learning development lifecycle goes. So some of the things you have to think about. So the question is, do I need a degree? Should I get a certificate, or do I need to do some self-study? So let's think about the things that you should consider. How is your math background, right? Have you taken calculus, probability, linear algebra? How about your current degree field? If you have a degree in the sciences or one of the quantitative social sciences, then that's going to affect things. And also, what's your current degree level? Do you have an undergraduate degree? Maybe you're still a student in an undergraduate, or a master's or a PhD. And then you have to consider your own personality, because some people are really good at self-study, and some people are really proactive about finding and completing projects. So deciding to do something, really sticking to it, and then completing it. And if you look at this list and you have sort of several one of these, right? If there are several of these that you have a math background. Let's say you have a BA or an MA or a BS or an MS in science or really a quantitative social science, and you're also pretty good at self-study. Chances are you're probably going to be able to get away with teaching yourself a lot of these techniques, or get a certificate. If you're missing many of these, then it might be that you have to go actually get a degree, and that could be a master's degree in machine learning, or sort of a more advanced certificate. But in my personal opinion, if you have a degree, so any degrees, if you have a bachelor or above, and you're motivated, then a graduate certificate is sufficient preparation. And what I mean by that is, if you can study enough to successfully complete a graduate certificate in machine learning of some sort, and there are many that are offered out there, and comment below if you've got really good resources or programs that you've seen or taken that you think are good. But if you have a degree of some sort and you're motivated and you have some mathematics background, then if you can get a graduate certificate successfully, that's going to be enough preparation for working in the field of AI ethics and governance. Because you also need to have these other skills that we've been talking about. You also need to be up on the literature, up on the use cases, what's being talked about and considered in AI ethics and AI governance, and all of the legal aspects. If you have those and you have, let's say, a graduate certificate, you're going to be more than prepared. Now, in my case, I don't have a graduate certificate. So if you have, let's say, all of the things that I listed, so I have a PhD, it's in astrophysics. I have a strong mathematics background, and I'm also quite motivated, and I can really focus and work through problems, and I'm fairly dedicated to self-study. I was able to basically gain the skills through the course of, I'd say, 4 years, maybe 4.5 years of dedicated work, where I feel that I'm comfortable with AI and machine learning development. And so if you have most of those things that I had on that list, you may not need a graduate certificate at all, and self-study may be enough. And you have to basically trust your judgment. You know, if you can take a project, what I mean by that is take a problem. You have data, you have a problem that you're trying to solve. If you're able to actually go from start to finish and develop a machine learning solution for that problem, then it's most likely that you're ready and you're prepared to actually apply that knowledge to AI ethics, governance, and consulting. So up next, we're gonna switch gears a little bit and talk about another technical topic, but this time I'm going to go a little bit deeper and provide a little insight as to how you might actually do something technical. And in this case, it's going to be bias testing.